Assalamualaikum and hi. Our group consists of 5 members, which are Nabila, Adrena, Nadira, Shazwani and Izzah. First of all, let's go through the question number 1 as shown on the screen. For question number 1A, write the initial value problem mathematically and in differential equation form that satisfies the temperature inside the house after midnight.
1A. First, we need to let T as a room temperature and Tm as outside environment temperature. Tm is the constant temperature of surrounding medium. Tm is equal to -7 degrees Celsius. Then, the rate of cooling of the room must be directly proportional to the temperature difference. And we got the equation is d capital T over d small letter t is equal to -k in bracket t plus 7. Initial value problem, also known as the Newton's law of cooling. Given T initial is T naught, which room temperature is equal to 23 degrees Celsius, and T after 2 hours is T2, which room temperature is 10 degrees Celsius, and we got D capital T over D small letter t is equal to -k in bracket T plus 7 as equation 1. So let's go to the question 1B, which is we need to solve initial value problems. Okay, firstly, we write D capital T over D small letter t is equal to -k in bracket T plus 7. And we integrate D capital T over in bracket T plus 7 equal to -k integrate D small letter t plus C. C is the integrating constant. Then we put log in front in bracket T plus 7 equal to -kt plus C, and we solved the problem and we got T is equal to -7 plus C the power of 1 exponent -kt. This is the equation 2. Now, given that T0 is equal to 23, hence we put 23 equal to -7 plus C the power of 1 exponent -kt. Then we inverse T naught. T is equal to 0 will get exponents. The power of 0 is equal to 1. And then we solve the problem and we will got C the power of 1 is equal to 30. And then we will got T is equal to -7 plus 30 exponent the power of -kt. This is equation 3. So let's given that T2 is equal to 10. So 10 is equal to -7 plus 30 exponent the power of -2k, which is we insert T equal to 2 will get exponent the power of -2k. Then we solve the problem. We will got e the power of -2k is equal to 30 over 17. And then we should take log both sides, and we will got k is equal to 1 over 2 log 30 over 17. Using equation 3, when k is equal to 1 over 2 log 30 over 70. So we should find equation 4. We put T equal to -7 plus 30 e the power of -1 over 2 log 30 over 70 t, and we will get T is equal to -7 plus 30 times 70 over 30, the power of t over 2. This is equation 4. And this is the required solution to the IVP1, which gives the room temperature T at any time. Let us verify it. The solution is correct. At t equal to 0, we got t0 is equal to 23, and at t equal to 2, we got t2 equal to 10. Part C in question 1. Using equation 4, t is equal to negative 7 plus 30 times 17 over 30, the power of t over 2. Let T1, a room temperature, reach 5 degrees Celsius. And then we put 5 equal to negative 7 plus 30 times 17 over 30, the power of T1 over 2. We got 12 over 30 equal to 70 over 30, the power of T1 over 2. And then we put a log both sides. It will show like log 2 over 5 equal to T1 over 2 log 70 over 30. And finally, we will got T1 equal to 3.23 hours. So 12 a.m. plus 3.23 hours is around 3:14 a.m. At T note, donate 12 midnight, hence the temperature inside the house will reach 5 degrees Celsius around 3:14 a.m.
Now, let's move to question number 2. The data given are 20,000 liters of pure water in tank, concentration of brine flow into the tank, which is 5 kg per liter, rate of brine flow into the tank, which is 20 liters per minute, and also rate of mixed solution flow out of the tank, which is 20 liters per minute. We wanted to find the amount of A of salt in kilograms in a tank at time t. Now, in order to solve this question, we need to use the equation of dA divided by dt is equal to R in minus R out, which A is the amount in kilogram of salt after t minute in the tank, R in is the rate of salt into the tank, and R out is rate of salt out of the tank. First, we need to find R in and R out. So R in is equal to 5 kg per liter times 20 liters per minute equal to 100 kg per minute. For R out is equal to A kilogram over 2000 liter times 20 liters per minute is equal to A kilogram divided by 1000 minutes. So now we get the differential equation, which is dA divided by dt is equal to 100 kg per minute minus A kilogram divided by 1000 minutes. If we simplify this equation, we will get dA divided by dt is equal to 100,000 kilogram minus A kilogram divided by 1000 minutes. Next, we need to separate A and T, and we will get 1 divided by 100,000 minus A dA equal to 1 divided by 1000 dt. We need to integrate both left and right hand side. For integration of the left hand side, we can use substitution method to solve it. So, let S is equal to 100,000 minus A. So, ds divided by dA is equal to negative 1. dA is equal to negative ds. Next, we need to substitute negative 1 and negative ds into the equation, and we will get integration of 1 divided by s times negative ds. We can bring negative 1 out, and then we solve integration of 1 divided by s ds, and then we will get negative 1 ln s. After that, we substitute the amount of s into the equation, and we will get negative 1 ln 100,000 minus E. That's it for the integration on the left hand side. Now we can continue the integration on the right hand side. we integrate 1 divided by 1000 dt, and we will get 1 divided by 1000 t plus c. Now that we have solved left and right hand side, we need to simplify the equation. Next, we can multiply -1 to both right and left hand side. And then, since we have ln on the left hand side and we wanted to get rid of it, we can multiply exponential to both right and left hand side. Now, for left hand side, we can cancel ln and exponential. And then for the right hand side, we can put c to the front. And then we will get a new equation, which is in modulus 100,000 minus a is equal to c exponential power of -1 divided by 1000 t. Since we have modulus on the left hand side, so the answer on the right hand side will be either positive or negative. The goal now is to find a. So now, let's use the positive equation first. So 100,000 minus a is equal to c exponential power of -1 divided by 1000 t. So a is equal to 100,000 minus c exponential power -1 divided by 1000 t. And for the -1, we have 100,000 minus a is equal to negative c exponential power of -1 divided by 1000 t equal to a is equal to 100,000 plus c exponential power of -100 t. Since we begin with pure water, so we have a in bracket 0 is equal to 0. And then we need to substitute this value into the equations. For the first equation, 0 is equal to 100,000 minus c exponential power of -0 divided by 1000. So we have 0 is equal to 100,000 minus c, and then we can get c which is equal to 100,000. For the second equation, which is 0 is equal to 100,000 plus c exponential power of -0 divided by 1000. So we have 0 is equal to 100,000 plus c. So we get c is equal to -100,000. One will be rejected. So we have c is equal to 100,000. So our function is a is equal to 100,000 minus 100,000 exponential power of -t divided by 1000. So from this, we can conclude that the amount of A salt in kilograms in a tank at time t is A is equal to 100,000 minus 100,000 exponential power of -t divided by 1000.